Hello guys, welcome back to my YouTube channel. It's me Aradha Gopal Nepal, and in this video I am going to explain how to do encryption using RSA and hybrid encryption. For you, for the sake of example, I will be using Esewa and Khalti for demo. So let's see this API. So I will be encrypting these two key of Khalti and Esewa for this demonstration using RSA and hybrid. So Esewa and Khalti are Nepali payments SDK, and if you are some abroad guy watching this video, you don't have to worry because this video is very generic video. You can just skip to next time stamp of this video and get started on how to do the encryption part. This video actually a part of a series named uh, Flutter.net integrating Esewa and Khalti, and this is the third video nicely explained. So in first and second video I've done my own exploration and roughly I learned how to do these things, but in this video I will explain you nicely. So in this time stem I'm going to teach you. So since this is also a part of Esewa and Khalti integration in .NET and Flutter, in this video this timestamp I'm going to teach you what are the steps on Esewa and Khalti integration. So nicely on Flutter, not on web. It's nicely explained. RSA and hybrid. Okay, let's get started. So in Esewa and Khalti, so I've divided the API part in three part. Okay, the first part is get SDK 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 sorry guys, SDK keys and product details. So the second step is get transaction ID. Third step is verify transaction. So in part one I've done this part of the Esewa and Khalti integration. In next video I will explain this, but in this video also I will summarize this part in a short way. So the first step is get SDK keys and product details. Again, if you are not don't know what is Esewa and Khalti and are upload from Nepal, you can skip to next time spam. So Esewa integration, for Esewa integration and Khalti integration. So as you can see, for Esewa integration in Flutter, okay, let's start from Khalti. So for Khalti integration, you need this public key. And thing to notice is that this public key is on inheritance widget. What does it means that you need this public key before user presses the confirm and do payment button. And for the sake of knowledge, it is a bad idea to put Khalti scope on material app. You should get this data from backend, and you have to put this Khalti scope on most descendant widget like the elevated widget. You have to put this Khalti scope, and this data must be dynamic, which must come from backend. And you also need these details. So as get transaction ID, so this product identifier is a unique ID for that specific transaction. And if something bad happen during your transaction using this product identifier, backend guy can track what is the status of the payment. Okay. So in first step, we need to get SDK keys and product details. So these are the SDK keys. So these are the SDK keys. This and Flutter. These three are the STK keys, and these are other details we need for payment. These details which we will get in this API. Among these detail, oh sorry, not these detail. Among the detail, there is product ID and product identifier. This denote an specific transaction, and this detail will only get when we click confirm and start transaction just before opening the SDK UI. So in next video, I will make a separate API to get this transaction ID. Using this transaction ID, we can we can track the status of what is happening with that transaction. So sometimes what happens is Esewa that user have done the payment, the balance from their bank account deducted, but suddenly while they are verifying using this ref ID, which I will teach you in this step, verify transaction, backend is down. So in that case, we need this transaction ID to track. So that's a short introduction about Khalti Esewa. In future video, I will explain in more better way. So here are the keys of this SDK. So I will simply explain the code base. So at first I have done this setup, and as you can see there is a database. I will show you database. So this is the database, and there is only one table, and for now there is an assumption that for every ID there is a separate merchant. For example, there is iPhone 12, and every payment done in iPhone 12 will be sent to one merchant wallet. So that's the assumption. And for every product ID, there is a separate table, separate client ID. Every detail is separate. So this is the database basic information. So this is the connection. This is I am doing dependency injection. After that, I have also done this, false. So I'm actually new to .NET. I know more about Flutter. So here is the DB context, and there is a product merchant detail model, and this is the model. It is the previous database I just showed. So in request, I will ask product ID. In response, I will got Khalti and Esewa details. As Khalti and Esewa details, as you can see. So this is the payment basic API. So this is the API, and as you can see, if I write one, it will show me item not found. It if I write two, which is existed on database, it will give me details. This is called the key. So these are all of the things I've done in part one of the video. But the problem with the part one was that this key and this key are the key of merchant, and in current database any user can access this key. All they need is to log in, get access token, and hit the API, they can get this key. So to make our data secure, we should do some kind of encryption in this video, and that's the agenda of the part 2 I've done in this series, or the next timestamp of this current video. And I'm a Flutter developer, and why I am learning and explaining this is that as a Flutter developer, if you know this thing, you can easily guide your backend. Otherwise, your backend will be confused. What your backend do is they will see the documentation of web integration called the API, and they will make the API for web integration, but for Flutter, it's completely different. So this series helps you for Flutter specific integration. So if you are so there are two kind of user who will watch this video. Either who are interested in encryption using RSA and Hybrid, or who are interested in Flutter and who are interested in Khalti and Flutter using Khalti and Esewa using Flutter. The guys who are interested in Khalti and Esewa using Flutter, they can, if they watch all of the video, they can guide backend better and make their product better. So so that's all explanation of first video. I will do check out. Create status. Sorry guys, I should have closed this. Hello guys. So this is the next time stamp of this video, and it is where I actually teach you how you can do RSA and hybrid encryption and decryption in .NET. And first I wanna say sorry for the folder structure because I'm not originally .NET developer. I'm a Flutter developer, so folder structure is not that good. But I ensure that in future I will make this folder structure better and do proper research of how to do better, folder structuring. My video is being recorded. So let's get started on this video about encryption. Okay, this is not. So first let's know what is RSA versus AES encryption. So as you can see, AES is a symmetric algorithm designed for rapid data encryption decryption. RSA is a asymmetric method used for premise. You can read this kind of things. I need to find some better. So I will explain myself. Okay, what is here is so in AES, what happens is there is one key. There is one secret key. Say 1 2 3 4 5, and both the sender and receiver both sender and receiver have those key, both have that 1 2 3 4 5 key. And when sender sends a data, so data is equal to hello. So this is sender. Okay, when sender sends the data, what he does is that data dot encrypt, say key is equal to, so it will encrypt the data with that key and sends it. And the receiver s- receives it, and now it, okay, and now it decrypt it. So one thing you note is that both sender and receiver encrypt and decrypt the data with the same key. The problem is sometimes, one of the member could be, bad guy, and they can misuse the data. So there are second way of encryption which I like, that is RSA encryption. And what happens is that, so for now I am explaining on this sender and receiver. Okay, so let's say receiver have some private receiver have private key, and public key. Okay, and what happens is that receiver, private key of receiver, public key of receiver. So what happens is that receiver sends this private key, I mean public key, to the sender. Send it by receiver, and receiver says to the sender that whenever, so receiver says to the sender that whenever you send any data to me, encrypt it using this public key, and that data cannot be decrypted even by the sender. In order to decrypt that data, this we need that private key, and private key is only available to the receiver. What it means that what it means that this data is equal to one hello, and public key is equal to public dot, 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 and private is equal to private dot, 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 and the sender So data dot encrypt using public sender encrypt data using public key and sends it to the receiver. Now it's receiver. So and it receive the data, encrypted data, and encrypted data dot decrypt what private key. So this is the data flow. One thing why I like RSA over AES that sender can decrypt the data. Sender can decrypt the data, or if sender mistakenly exposes the key, the data gets leaked. But that's not a case on this encryption, because even if public key get leaked, no one can decrypt it because only receiver have the private key. So by this what happens that the receiver can openly share the public key to the sender without concerning about whether the public key can be leaked. So that's the one of the main advantage I found, is that they can easily send the key, even Gmail, WhatsApp, this key they can share it and they do not have to worry that it get leaked. So that is the main advantage I found. That's why I love RSA over AES. But why while doing the coding, I was continuously facing one problem in RSA, that RSA was not able to you know encrypt a large amount of data. RSA encrypt large data error in Flutter. So I was continuously facing this kind of error in Flutter Dart. And in Flutter, what I found, one solution was to do chunking. What chunking is that there is a large data and we break large data have error in RSA, and what I found in Flutter was chunking. In chunking, we break down the large data and decrypt the specific chunk small by small, and at the end combine those data and sends it, and the same way the data get decrypted. So that's what I learned in Flutter. But when I was doing my research morning on .NET, what I found that using chunking for decryption is a bad idea in RSA, because RSA is made to encrypt only short data. So let's search in RSA encrypt large data in .NET. You can see encrypt data that is shorter length, so not will do is. So I search. You can search it yourself. Okay. So while doing this research, what I found is that, so in Flutter, so one of the thing about Flutter is, it's just 5 6 year Flutter had been come, and the developers are like experience of 5 6 year, and nobody suggested me that we should not use RSA for large data. All they suggested to me that you should do chunking for large data. But when I got into the .NET community, what I come to know from experienced developer, look, this post is posted on how much, 12 years ago. Okay, 12 in this state Flutter was not even started, but this encrypting strategy was already started. And what I learned is that for large amount data, never use RSA encryption, use what, hybrid encryption. And again, I wanna compliment the .NET community, which have more experienced developer, like 5 years. Just this post is just 5 year, okay. And In Flutter, I was easily finding codes of how to do chunking, but even I tried to find the code of how to do chunking in .NET. All of them suggested me do not do it. Just do hybrid is better. And the steps of hybrid is that like this. Okay, so let's say sender. What sender is? Sender have the public key of receiver, and receiver have public private key of receiver, his own private key, because private key is owned by the person itself. It's not get leaked to any other party. So what happens is that the step one is sender creates a random AES key. Okay, and as what I learned today is that AES is a good way to encrypt any amount of large data, because all of the encryption happen in streaming itself. We don't have to worry about how large the data is. So it's a perfect thing to encrypt large data. What sender does? Sender encrypt the data large data, just save it on some variable large data, and creates encrypted large data. So it's 9:07 p.m. So my laptop is turning blue ray free. Okay, sender encrypt the large data, creates the large data. The point to be noticed, this encryption is done using AES key. That's the most important point we should remember, is that AES key is used to encrypt that large data. And the step 3 is now where the role of public key comes is here. Public key is the AES key. I hope I'm writing AES spelling correct, guys. AE AES versus RSA. Yes, A is correct. This get encrypted by the public key. Now, now we got encrypted AES. That is encrypted AES. That is decryption key. So AES is a small amount of data. It is not a large data. So encrypting the AES key using public key, or encrypting the AES key using RSA, is a good strategy, and it is efficient. And in response, receiver sends the two data, encrypted large data and encrypted AES decryption key to the receiver. Okay, and as per ChatGPT, yes, it's also good to send metadata regarding which algorithm is used to this, as per ChatGPT. Let's consider. So this is the process which happens on the sender. So using RSA, it is just encrypted this key, small amount of key, and using AES, it is encrypted large amount of data. So perfectly encryption happened here. Now the receiver have private key. So receiver have the private key of itself, and as you all know, this encrypted AES can only be decrypted by this private key, because it was encrypted by this public key of that receiver. So let's begin the process here. At first, what happens is that receiver receives from the sender. After this, using its private key, decrypt the and gets the AES key, randomly generated AES key, AES key. So this is where the RSA decryption come on the side of receiver. So we got the AES key, and AES key is the key from which the data was encrypted. In third step, using that AES key, the data data gets decrypted, and we got the decrypted large data. So this is the workflow of in hybrid encryption decryption, hybrid encryption decryption for large data. So this is all of the theory which I learned today in morning's 2 hour video. And so theory ends here. In the next section, next timestamp of this video, I'm going to explain just little bit about code, about how I practically demonstrated this theory. So I will have a break, and let's see in next timestamp. Hello guys, so I'm back with a short break. So in this timestamp, I'm going to explain practically how in the code I have implemented the RSA and hybrid encryption. So what I've done is that, so as if so in my response there were two data. Okay, so first were data of Esewa. So if you are outside is Nepal, you don't have to understand anything regarding what is Esewa, what is Khalti. Just understand that we need some Esewa and Khalti is payment SDK of Nepal, and we need to send the front end some key of this SDK, and we are encrypting this key. Okay, these are two payment SDK, and for Esewa, what I'm using is I'm using hybrid encryption for demonstration, and for Khalti I'm using RSA encryption. I'm not using AES encryption in because I don't got thought, but in since Esewa have hybrid, it also include AES encryption. So let's start with Khalti because it is easier than Esewa. Okay. Okay. So uh, first I want to say let's look on the file. Again, sorry for the folder structuring. I'm not a .NET developer. In future, I will do more research and make a clean architecture because for now, the codes, let's say, look, payment detail request response. So in response, in DTO, I've done lots of logic, and I don't think this is a good strategy to do logic in model because in Flutter, in model, if any junior do this kind of logic, I will scold them. But for now, I've done it. I will refactor and put logic on its respective layers. So with that, let's begin to our content. So let's look RSA encryption using ChatGPT code. What I did was I created encrypt bytes method. It input and it requires RSA key. This RSA key must contain, you know, this RSA key is public key. Okay, public key, and using that public key, it encrypts the data. And there is also this decrypt method. This private key is private key, and this using this private key it decrypt. Okay, there's two decrypt bytes which turn white, decrypt string which turn string. It's a simple thing, and combine is because I've used chunking. So using RSA, we should not encrypt or decrypt large amount of data, but for this demonstration I have used chunking, to decrypt or encrypt. So what is what is happening, guys? Sorry guys, I don't know much about. So chunking was used if there is large data. It is bad strategy than hybrid, but for demonstration, it was done. So there is chunking done here to encrypt, and we combine. So we encrypt these 100 lines. We divide them in, 100 parts. For every part, we will encrypt, and at the end, we will combine. All code was generated with ChatGPT. This is encrypt decrypt. Okay. And for testing, I've used controller for testing. And again, sorry for this because of because look, I'm Flutter developer. I don't know how to do unit test in .NET. So I created an API itself to do the testing. That's so funny. And the what's the even more worst part is that backend contains the mobile private key. So backend containing mobile public key is completely okay, but backend containing mobile private key is not okay. But for testing, I've done this. But in actual, if in production, if you actually want to test, you know, you should not use actual public and private key. You should, generate a new public and private key and then do testing on your unit test. I don't know how to do in .NET, but I will do it. Don't worry, okay? Every bad thing in this code, I will do and refactor it in future commits, and I will also make video about it. So, so that is how I've done testing. So look, using public key, this is data, and I encrypted the data using that public key. Look, RSA have that public key. I've encrypted the data using that public key. So this is encrypted byte, and I've again decrypted the data using private key. Inside, look, there is uh, decryption happening using that private key. This is how RSA works. And so one thing by doing this, one thing I found, what to say, one thing I found new learning or whatever is that there's something a bit I also knew it previously, but I got more exposed to it. That is something called base 64. Base 64 is a data which is useful when we are sending a data in API. In any response, we cannot send just binary data or any string data because the data format could not match the requirement of the response. So when you are sending the encrypted data in the response, look, the format of encrypted data is byte list. We should not send this byte list on response. We should encode it in base 64. So there is also another way which we should not do. So there is something called UTF-8. That's we can also do this. So what I learned today is what is UTF-8 is that this is binary data, and what UTF-8 does, it converts binary data to string, or vice versa. It converts string to that binary data. But while we are sending data to in response, never send in UTF-8, send it in base 64. So basically base 64 is what we send in response, and when front end or the client receive the data, the first thing they do is they decrypt the base 64. In decrypt, there is no base 64. Okay, that's in decrypt, there must be base 64. So this is encrypted data. So what is happening in test, I will show later. In test, no, this same data is getting decrypted. I will show in next example decrypting of base 64. And now come internal. So internally, so when we need to get an string as a output, but the encryption decryption output is byte, we use UTF-8. UTF-8 is to denote list byte data into string. Just same thing, whatever, so, and in response we are returning this DTO, this basic DTO for purpose of testing. Again, use unit test, do not use this controller to do testing. I will run the, okay, and let me explain some variable, okay. Plain text is the actual text, original text. Encrypted byte is what text is comes after encryption. This is encrypted byte is something we sends to the front end or the client. This decrypted text is something that the client decrypts and gets how it gets the data. Okay, let's try it out. Execute. Original data. This is something we send in response. It is base 64 to the client, and client decrypts it and gets this data. So that's regarding RSA encryption, and this is one util I made to make this encryption better. It's the same thing, just a util. So one thing I want to say is that I didn't know how to do to testing in .NET, but I've created in this test API. So if you are backend, please test your API before giving it to frontend, especially situation like this, like encryption decryption, because you might have encrypted data and you might have encrypted in bad way, and the frontend will waste its entire day thinking that backend has encrypted in corrected way, and frontend didn't figure it out how to encrypt it. So frontend might be thinking that it's frontend problem, and they will waste entire day. So whenever you are developing API, especially like encryption decryption, always do proper testing, please. Okay, so this is the encryption, and let's the final. This is the encryption, and when we combine in its real world, so this is payment controller. Okay, so for now I've used a bad layering in DTO. We are doing encryption. So this is Khalti details. This is a string. This Khalti details get encrypted. I've created this helper class. So this is the test of helper class, and using the public key it encrypted data and returns a base 64. So Khalti base 64 get returned here. Okay, let's try it out. This API. So this, ignore this below part, I will explain later. This is the this is the RSA encrypted base 64 data. Okay, now to test, so again, whenever we are backend, we have to test whether our API is correct or not, because frontend will suffer bad if you don't test, especially in this. Please test. So in order to test, I don't know how to write unit test, so I've created this controller to do testing. So let's see here. Okay, so as you can see, the first thing, so this is the testing for Khalti, where we have to enter the encrypted data and we have to execute it. When we execute it, this is base 64. The first thing happen is base 64 is my video is recorded. Yes, it is being recorded. The first thing happened is the base 64 get decrypted and it's byte of array. We could use ut what utf8 something to get string out of this byte of array, but since our other method requires the byte of array, we don't have to do it. Okay, so it decrypts that byte of array. For decryption it requires private key. Again, as I previously said, backend never have the private key. Just since this is the test and I didn't know how to write unit test, and I've used same private key of mobile, I'm using this mobile private key. Otherwise, in order to do test, we have to create a new public key and a new private key and do this kind of testing. So we have decrypted the data. This is the actual data, called the data in JSON. We have deserialized it, and after deserialization we have returned the RSA. It's just JSON using DTO. Data get returned. Let's see how it looks. Look, here is the data. So from this encrypted data we got this data, and these tasks, so these tasks is not done in backend. For testing only I'm doing it here, Actually, this is done by the front end. In this way, they use private key. This. Okay. So this is about RSA. Now let's move towards hybrid. Sep, sep. Let's go to this code. So again, I'm just explaining code line by line. If you want to know how I have coded, you can watch my previous video. It's 2 hours, so there are lots of boilerplates on the video. It should be string string. I get confused in .NET, you know what to put. So as you can see that this method, this method will generate an AES key. This method requires data, and this method requires that AES key and data, at then it will encrypt any amount of large data. As you can see, it will just stream, and you can encrypting large amount data is no problem in this code. I don't know much about this IB, but from what I know, initializer vector, every time it will return new kind of encrypted value, so that the hacker cannot. So password 12345, hacker encrypt it, and if means they can compare. 12345 have same encrypted value as someone other user who have set their password as 12345. Is this same both? They might hack. So I will explain this here. Without. So this is what I know. I might know wrong. So if I am wrong, please correct me. So hacker got 12345 is A B C D E. A user password is 12345. Hacker hacked the API and found the encrypted data A B C D E. Now since 12345 which hacker denotes A B C D E and the user password encrypted is also A B C D E, that so the user password is 12345, hence hack. So this is what happens without IB. What I know, but with IB. So hacker got 12345 is ABCDEE, but and user seed password. But every time no this ABCDEE is get encrypted, it could be EFGHI or this or this or this. It would be different, not same. Okay. So if hacker found the encrypted key is this, it also is. Wait a minute, bro. I will pause my video. So guys, back. So I was trying to be show you hacker's perspective. So the user password is also is actually encrypted as so so hacker cannot know that it's 12345. Same every time it would be encrypted. So as per what I know, that's what this initializer vector do, and it will encrypt the string, and same with decryption, it will decrypt it. And as you see, there is using stream and stream and stream. So this is it can more efficiently encrypt and decrypt the large data. So that is about AES. Now let's move on. So now let's move on test. Again, use use automated test, not this controller test, but for demonstration I'm doing it. Okay, ठीक है? हाँ. So this is AES encryption. I got data, I got key, I encrypt it, I decrypt it. This is the original data, this is the encrypted data, this is decrypted data. And so this encrypted data is sent to the user in base64 format. The user decrypt that data, and the data which was original and the data which was original and the data the data which was original generated by the sender and the data which is decrypted by the receiver must be same. I will show you this later. And this is the hybrid encryption. Okay, I have written step by step. This is the data, this is the key, and so this is the large data. And using this key, we encrypt that large data, and we got the large encrypted response. Okay, and encrypted value. I am naming my naming is bad. We got large data. So this is the large data encrypted. This is the AES encrypted key for decrypting the large data. So encrypted value, and obviously whenever we are sending data on the response, we must encode in base64. So this is two data. This is one data, data one we send to in response. Or this is the data two we sent in response. Okay, now client received the data. The first thing it do is that it will decode the base64. So this is the base64, it decodes it, get byte of array. So we can also, UTF dot something something something. We can decode this byte list and convert it in a string. But since this method requires byte in itself, we are not decoding. We are just passing it here. And what it do is that decrypt. So I'm writing comment uselessly because it's like there is a danger sign, and above the danger sign I'm writing this is danger sign comment. But for explaining in video I'm doing this. Decrypt the AES key, the AES key. That's what happening here. Okay, we are decrypting the AES key, which is decoded properly, and we got the decrypted key. And the point comes here. So look, this is AES decryption. My naming of this folder is bad. This is AES decryption of large en- encrypted data. Okay, so using that AES key, which we recently decrypted using RSA algorithm, we are decrypting large data. And here we got, with this we got all of our record data. So again I will say that, so what we are doing, we are encrypting large data using AES, and we are encrypting that small AES data using RSA public key. We are sending it to the client by encoding in base64. When client receive it, first decode in base64, then it will first decode the AES decryption encoded key using RSA public key, which is a short data. So RSA perfectly fine for short data. And after decoding the AES key, it will again decode the encoded large data AES key. AES key works perfectly for decoding large data, and we got our final result. So this is the main data we want. As a receiver, we don't care about decrypted key. We care about this decrypted response. Decrypted key is only useful for decrypting this keys data. So at the end, we got our data. So I will run this to test and show you. Okay, AES, try it out. So this is our data, a large data. Okay, this is our using AES. We have encrypted the large data, and this encrypted is base 64. The receiver received this base 64, and using the same. So in AES, both sender and receiver have the key. The receiver received the base 64, and using the key it have, which was used to encrypt this data, the receiver decodes it, and the receiver have this data, and both are same as you can see in boolean, and you can see in test case. So again on the test using hybrid, so this is the original data, and using this key, okay, using this key, this original data was encrypted, and this is what is the result. So this large data is encrypted using this AES key. This is the result, and this small AES key is encrypted using RSA public key, and this is the encrypted AES key. This encrypted data and this encrypted AES key is converted to base 64 and sent in response to the client. So now the client have this encrypted data and this encrypted key. Client also have its private key, private RSA key. But since this is large data, client cannot decode this data using private key. Neither this data was encoded using public key of that private key. I might making confused, but I hope you're understanding it. So using the private key which the receiver have, it decodes this data, this encrypted key, it decodes it and it get this key. So both key are same as you can see. My code is working, my test is working. So this key the receiver gets. After getting this key, the receiver at first receiver convert this base 64 into byte list. After that the receiver decodes this encrypted data using this decrypted key, and after that they got these final results. So all of this process was done just to get this decrypted data, and as you can see the data is same. So in this way, using hybrid encryption, we have properly encrypted the large data, and we have properly decrypted the large data in a secure way and both efficient way. RSA for short data like key, and AES for large data like actual data. Lots of talking by me. Now let's do integration test on bad way. Obviously we have to write a unit test, but here I'm doing bad way. That's one thing. Okay, there is 1M 9U. Let's run it again. 7J FC. Run it again. FRJB. There is, so every time I'm running, a new kind of data is getting generated because I have used an IB. So this is what I know. It is being this kind of different data is generated because I have used this initialization vector, so that as I've already shown in this diagram, the hacker cannot check like this and hack your data. So this is, now let's also check about this Q1. Okay, this is also being different. I don't know how it is being different. Let's check it out. RSA do it generate new encrypted data every time. Generate the same pair of every time because it is highly unlikely for two different keys to the same value. I don't know what is happening, why it is generating different data. It could be also due to base 64 decoding. I don't know. Let's try it. It does base 64 returns different data for every time. Go data the same in order. So I don't know why in this case we are getting different data, but in this case we are getting different data due to IB as per my knowledge. So now just copy this and do our integration testing in a bad way using controller itself. In future video I will make u- actual unit test. But one thing I want to say again, if you're any backend, please do your testing before you send this kind of data to us. And here we are, we got our data. And moving to code, here is our code, okay? Testing actual Esewa. This is the code which front end will do, but for in our scenario, for testing, I am doing it. And I'm doing testing on bad way. So at first we got this data. It is encoded in base64 to easily send data in response. We decode the data in base64. We get byte of list. So we could have done UTF-8 something if we wanted this data on string. But since we don't want and this method requires byte, we are sending data. And for decrypting it, so we got two data from response. First is encrypted data. Our main agenda is to get this decrypted data. The second is encrypted decryption key. So AES key which is decrypted. So what at first we are decrypting the AES key, which will further decrypt this data. So we are decrypting the AES key. So for now, it is a bad practice, but for testing, we got our mobile private key, and in RSA we are decrypting the data using private key. But in reality, it's the mobile which have. So this is the code which will be run by mobile. So we got the decryption key. We should not print it here. And using that decryption key, we will decrypt this thing using AES. So this is AES decryption for large data. So large data. So and this is R RSC. I forgot, bro. RSA for short data. So short data. So large data get decrypted and converting JSON and here there, and finally we got this response. Okay, finally I will repeat the same boring part that in hybrid I will not repeat. Okay guys, that's all for my video. So okay, my video finally comes to an end here. I will say a bye bye by showing my face and will end this video. Thanks for watching up to here. If you have watched this video in detail, I hope you understand it better. So I'm using OBS for recording, and I'm using my laptop does not have front camera, so I have to connect to my mobile if I want to share my face. Okay, my face is ready. CMD video play SCRCPY. It's large screen which will come for 1 minute. Hmm. I will just make exact 1 hour video. Just 30 seconds remaining. So thank you guys for watching my video. Hope you learned lots about RSA and hybrid encryption. And this video is not only this video is about RSA and hybrid encryption, but it's also about a part of my series Khalti and Esewa. So if you're also watching this for Khalti Esewa, keep watching because in future video I will upload other things about Khalti and Esewa. Thank you.